So welcome to our October Physics Matter Colloquia series. And we are focusing today on Physics Without Frontiers. So this is our 19th edition of the live version of Physics Matter Colloquia series, which is prepared by the Forum on International Physics, the FIP, in the framework of the Physics for Development program at the American Physical Society, the APS. So our live online event primarily targets the Center of Excellence for the partner countries of the SESAME light source, but as well the broader public. So ranging from early career scientists in developing communities to anyone curious to learn more about our exciting scientific world, where physics matter and where the value of collaboration can open new gates for developing community. So today, the perfect topic is physics without matter. So this is completely in line with our mission. So Dr. Kate Shaw will introduce their initiative and effort to enhance physics for the development in international collaboration. So the member from our FIP panel, so today with Joe Nimela from the ICTP and myself, so from the share line. So I work at the European Spallation Source in Sweden, and so we are in the share line. So together we want to create this flow of ideas. So bring us as well your comment back. So we would really appreciate your feedback. So we recall also that Kate gave a short introduction. So during last Physics Matter series, the forum, which was organized for science to facilitating human heritage. So where we navigated so across space and time to transcend the frontier and across and to know and access more knowledge thanks to scientific innovation. So please visit our webpage where you can find much more of those precious recordings and all the different slides and material that we have put together. And you can know more also about our guest then. So our guest today, so Kate Shaw, so she's an experimental physicist, so working in the ATLAS experiment at CERN and at DUNE experiment at Fermilab, focusing on area on top physics, neutrino physics, luminosity calibration and measurement, open data and communication. So she's currently the DUNE Outreach Coordinator, Director for International Affairs in the Department of Physics in the Success and ATLAS Open Data Convener. So she was the ATLAS Outreach Coordinator in 2013 till 2019. And previously on the ATLAS Inclusion and Diversity Committee. So Kate has also worked to promote physics in developing community. And in 2012, she funded and co-directed the ICTP Physics Without Frontiers programs. So which works to train and motivate physics and mathematics university students in developing countries with cutting-edge research and to motivate them to continue their studies and to consider a career in research, so through a voluntary network of scientists. So she won the European Physical Society Outreach Prize in 2015 and the Success Best, the Better World Award in 2021. So what we discussed was as well to have then now for her presentation, the possibility to interact with you during her presentation. So you have on your screen, so the possibility to raise your hand or to put question in the question and A section. So don't hesitate during that presentation. And we can then have the possibility to intervene and make something a bit more dynamic. So with this short introduction, then Kate, and the floor is yours.
Thank you, Christine. Okay, I'm sharing my screen. Is that coming across okay?
Yeah.
Wonderful. Okay, good afternoon or good morning to everybody. It's my pleasure to be talking to you today on the Physics Matters Colloquium. So the topic of my talk today is going to be about physics for sustainable development and for international cooperation. So this is all centered around the Sustainable Development Goals that were put in place by the UN to go towards achieving our goals and addressing our challenges by 2030. So you can see the 17 SDG goals in pictorial form on the right here. So we're looking about how science interplays with sustainable development. So at the currently, all countries, so at all income levels, from high income to low income, they are looking to transition towards digital and green economies. And they want to do this with the idea of achieving these sustainable development goals. And all this is to be commenced by 2030. So this, of course, vitally involves investment into science and accelerating technology transfer from science into industry. So you can see several of the goals here would, of course, benefit from many types of applied science, from technology transfer from science into industry. You can see clearly that science has a role to play. And in fundamental physics, so that's the kind of topic that I work in experimental particle physics, we also, along with the chain, we also directly work with quality education. So this is SDG number 4. So looking at how we can get physics and doing research into quality education and improving education in science for all levels. And we also work on, of course, gender equality and reducing inequalities. So reducing inequalities in countries by making sure that science is available and accessible by all. So research communities depend on having supportive policies and, of course, funding. And that is very, very different from country to country. Now, several countries have been improving and increasing their amount or their percentage of GDP that goes to R&D, but still there's 8 out of 10 countries, so 80% of countries are still devoting less than 1%. So this is something that UN are really pushing to change in order to actually achieve these SDGs. So more investment for more countries is really needed into R&D and scientific infrastructures. So this is just to talk a little bit about the chain of the different types of sciences and how they lead to sustainable development. So of course, investment into each of these 4 boxes. So starting with fundamental sciences, so that's the kind of science I do and many of my colleagues at CERN, or theoretical sciences, going into applied sciences, and then the technological and engineering and innovation. So that's interacting very much with industry and how can you transfer applied science into something useful. And that can go on to actually achieve this kind of sustainable development and go towards addressing some of the challenges. So the key takeaway here is that investment into each of these is equally important. It's very easy, or it's a very easy mistake to make, that to achieve your SDGs, you're going to just look at technology, engineering and innovation and look at how to address the challenges. But it's really important in all countries, as we'll go on to argue, to also be investing in fundamental sciences. So allowing scientists and lecturers at universities in all countries to be able to engage in fundamental science and in fundamental science collaborations. Okay, so this talks a little bit more about the discrepancy between the higher and the lower income countries. So it's often said that perhaps investment into fundamental science is more of a luxury of higher income countries. They can do things like particle physics or theoretical physics. But what lower income countries need to focus on is that technological transfer and the applied science. But many, many reports have said that this is a mistake. So the creation and transfer of scientific knowledge so the creation and transfer itself is critical in building this sustaining social economic environment. And you need to have these creators of this knowledge to really integrate that and be able to use that integration with the global economy. So that no regional nation can really just be a user of technology that comes out of fundamental science. You really need to have creators there as well. You need to have people in your scientific laboratories, in your scientific universities that can work with industry, that can work with how to adapt technology transfer. So the takeaway here is that really all countries have been obliged to review and reorganize their capabilities for accessing and benefiting from this high level knowledge. Okay, so in this kind of move towards digital and green economies, this is really about solving environmental, which is obviously extremely pressing, and developmental problems. And this really requires scientists and scientific and educational institutions. So these two things are key, what need to be invested in. So we need these scientific laboratories and institutions and infrastructure along with investment into scientists. So that means having good universities with professors that can teach students cutting edge research, having MSc and PhD opportunities within all countries that students can go on to further study. And of course, having these strong educational and scientific institutions, it actually trickles down to education at all levels. So if you have good university professors, if you invested into your scientific institutions as a country, that means that your undergraduate students will get this very useful access to international science and networks. And that means that those students with that good education will go on to advance the economy, of course, and some might become teachers, so that high schools have very good education towards young people. So it really does trickle down at all levels by having a strong scientific community, and that includes fundamental science. So along with this, you need, of course, investment into educational and technological institutions. Okay, so this is, I tried to find a little bit of data to show, to support some of these statements. So this is from the UNESCO Science Report, which came out earlier this year. And this is showing for a bunch of mostly higher income countries how money is spent and how much money comes in. So in the green, in the light and darker green, so this is comparing between 2014 to 2018. This shows what the global share of their total GDP. Now, of course, there's lots of arguments about if GDP is useful or not, but this is the data that we have. So in green, you can see how much of the global share of GDP each of these countries have. Okay, next to that shows the share of research expenditure, and you can see that in general, it's mostly matched pretty well with how much of the global share. So you'll see that most of these countries, they will be giving more of a share of their GDP, depending on how much more they have from the global share. And then in the kind of brown and the red over here, there's the share of researchers. And you can see again that it's more or less mapped from country to country. And then the share of publications. So I'd say the only outlier here, again, they should all be more or less mapped, but the European Union as a collective obviously has a lot of publications, even maybe more proportionally than compared to their research expenditure and GDP. And the same here also for patents. Okay, and I also just wanted to have a quick look at how much each country invests, because we're saying here that to achieve sustainable development, you need to invest into your R&D scientific programs. And of course, we're talking about all of science at the moment. These are numbers we have. I don't have specific ones just for physics at the moment. But this is comparing data from 2008 to 2018. Now, when the Sustainable Development Goals were introduced, many countries were actually thought to put in more money into their R&D programs, and you can see the general trend of an increase. So this is still proportionate percentage over time. People have put in more funding into their R&D programs. And you can see at the top here, the USA and China are absolutely top in the amount of funding they put in. Then we have the collective EU, and then Japan is really a leader. And then there's a little change of scale here before we see Germany, Korea, India, France, UK, and go on going down. And we'll see later that the US and China also have the largest share of researchers in science. And also you'll see that this really does transfer for both of these economies. Both of them are leading economies, and they can transfer their research, the funding they put into R&D into technological transfer and into their economies. Okay, so this is a kind of summary of what I'm going to talk about for the rest of the talk. The first slides were really to introduce the idea of the Sustainable Development Goals, and that science has a very clear place in achieving these goals and part of the pathway towards 2030. So it's clear that science brings technological, economic, and educational development. However, the UN would definitely say further investment is needed. We need to have, at the moment, with 80% of countries investing less than 1%, it really is not enough at the moment if we're really going to be addressing global challenges. Okay, so what else can we do? So everything from now on is more with a bent on physics rather than science in general, of course. But one of the key things we need to do in order to change the way we do science and be able to address challenges is to move much more towards open science and open data. Now, this has been a movement that's been going on for a few years now, and it's been pushed very much by many governments because you can really amplify the impact and benefits of the scientific research. And I'll talk a little bit more about that in the coming slides. Then, of course, there's importance of scientific literacy. So this is about the general public, the non-technical experts, people who are not scientists, engineers, and technicians, we need to communicate to the citizens the importance of science, how the scientific method itself works, make sure that students are educated through inquiry-based learning, and that adults can really benefit from understanding and digesting scientific data or scientific results when it's communicated to them. Another thing we need to do is, of course, international cooperation. So this is a really clear, important part of science, and it is a very important pathway, which I will motivate later, of how we can address global challenges. And the emphasis at the moment is really to improve international cooperation, in particular between countries in the South. And then finally, I'm going to talk about how science must be for all. At the moment, science is a little bit of an elite community. It has mostly scientists from richer countries. It's very much more dominated by certain groups. So this may include men, this may include certain ethnicities, and is a problem within countries and also across the world. We need to make science accessible to all. And I'm going to talk a bit about what we do in Physics Without Frontiers, the ICTP outreach program. Okay, so open science. So this is all about allowing scientific information, data, and outputs to be open, accessible, and readily harnessed to everybody across the world. Okay, so open science is really about helping to bridge the gap between some of the higher and lower income countries. We need to be able to share scientific output in order for the different countries to be able to access and benefit from that scientific knowledge. Open science also helps to promote equal opportunities for all scientists and also citizens. So open science implies that the scientific tools, data, and output should be available for everybody so that people can have access to this data and be able to see for themselves the latest and cutting edge results from the scientific community. And this will increase the scientific capacity and allow science education to flourish. And it also, of course, helps to support science as it's connected to societal needs. And this is important in aspects such as health, agriculture, technology, and its sustainable development. So this is really important, probably not so much in physics, but in other areas of science, that there's many issues that are local to a certain country or region, and they need local experts that have access to international resources. And then there's some issues that are global issues that requires international cooperation of scientists. Again, they need to be sharing data, sharing software, sharing tools. So open science is a key part of our mandate at CERN to make sure that through our experiments we release our data, and really this is provided for educational use in particular. So I'm sure you all have heard of CERN before. This is where the Large Hadron Collider is, where it collides protons inside of 4 detectors. The 2 are pictured here are CMS and Atlas. And these are both general purpose particle physics detectors, which measure the fundamental particles and interacting fields of the universe. So CERN has been a big leader in open data and has been doing this for, I would say, maybe 10 years plus now. They have an open data portal which allows the different experiments to upload their data along with any other tools or software used to analyze it. So they can be shared amongst researchers, but in particular can be used for training and education. We have all this wonderful software and data, proto-proton collisions from our experiment, and it's a wonderful resource to allow students to learn about particle physics, but also learn transferable skills such as programming or machine learning and other types of analysis techniques by using this data that we create at CERN. So this is the Atlas experiment, and this is the experiment that I work on. And I have also been working on the open data for this experiment. So we're a real international collaboration, just as CMS. And what we've done is collect together an amount of data from runs in the past, and we're about to do another big release soon. And we put it available on the web with a bunch of resources. You can see here a link that goes to our documentation, which has lots of tutorials, lots of educational workbooks, so that any young person can come and do these kind of exercises and be led step by step through how to do analyses. So Atlas provides, so it's real proton-proton collision data sets. And this is really fun to do with students because they actually, it's inspiring to do stuff with real data, not just being given some toy Monte Carlo, or, they're really working with real data sets. We of course supply Monte Carlo. So you can see in this plot here where we have an analysis to find the Higgs boson. This is a Higgs to 2 Zs decaying into 4 leptons. You have the data that they get to analyze, but you also need the Monte Carlo in order to make your backgrounds. And here's our Higgs boson here at 125 GeV. So the students actually rediscover the Higgs themselves. And we also do some Monte Carlo with new physics. So this could be gravitons, this could be supersymmetric particles. So the students can actually try, we want them to do inquiry-based learning. So not just to do education that we give to them, to allow students to explore the data. What particle they like to search for? What kind of analysis techniques can they use in order to search for new physics? And this is an incredibly important resource that we've used in the program Physics Without Frontiers, which I'll discuss later, so that students in countries that don't have access to working at CERN and don't have universities involved in the CERN project, every student has access to the open data and to the tools and educational tutorials. And so everybody gets access to the open data. So we make, I won't go into all the details, but we really do make, all the, a bunch of software, both in Python and C++. Some of it's available online through Jupyter Notebooks, but we also provide it on virtual machines, which you can download, and even on USB keys. So we try to be different for different needs of different students. And the key thing is that not just about learning particle physics, it's also about the kind of transferable skills you get from particle physics. So this is a different type of analysis techniques, understanding of how statistics are evaluated. And of course, you can do programming skills, and we've developed tutorials recently for introduction to machine learning. And along with that, we also know that not all students know Python, and maybe we want people younger than undergraduate students worldwide to be able to access Atlas data. So we also work on interactive data visualization apps. Here's a kind of GIF of one example. We're working on several more so that students that have, don't know how to program and, we don't have time to start a whole course in Python or C++, but they can still gain a lot of information from working with these interactive applications. So here they can do analysis to find the Higgs boson by just clicking on histograms with their mouse. And we've developed this also for rare top decays, and we're going to just develop it for much more analyses so that students can get all the kind of learning objectives, but skipping the programming if they haven't got trained in that yet. So open science is clearly an accelerator for the Sustainable Development Goals, and it's really a powerful tool to bridge the science divide. Now that students in every country get access to CERN data and all the tools that we're using to do the analysis, this means that those students will be able to put this on their applications when they go for further study, and that helps bridge that gap between higher and lower income countries. So this allows the scientific process in general to be more transparent, inclusive and democratic. I've kind of focused here more on the open educational resources, but you can learn all about the different ways of inviting your science to be more open through the UN portal. And there's still, of course, issues with access to publications. Around 70% of publications are inaccessible for students and scientists in lower income countries. And this is still a huge problem, and the open science agenda and movement is really trying to change this. Okay, so the next topic after a discussion of the open science is about scientific literacy. So just to give the kind of the definition, scientific literacy is about targeting the wider populations. This is not researchers, not technicians or engineers, everybody else. And this is done through science communication, education and outreach. So then I got this nice quote also from the UNESCO Science Report, when there was a reflection group of UNESCO's that met late 2020. And this economist said, "Science is in crisis. We have seen it clearly during the pandemic, but also in relation to climate change. Over the last 20 years or so, we have seen growth in the idea that science is just a belief like any other, and this is very dangerous." So scientific literacy is incredibly important for people, and especially young people, to learn. So not just to have access to science, so that people can make informed choices about global issues such as a global pandemic or climate change. So improving scientific literacy, this is really about from school level, so from primary school onwards, to benefit from inquiry-based learning. And this is a really important thing for all young people to learn. So this is observation, measurement and experimentation. And that will make students, whatever they get into, more able to access and digest facts. And this is really important also when you come to political issues. So when you understand how scientific discovery works and how the scientific method progresses, it's a real clear understanding that it thrives on uncertainty. In science, we have a continual readjustment as new facts come in. Okay, and that is something that we clearly know about in science. So, of course, when somebody's being interviewed about the state of the pandemic, or maybe about ideas we have about dark matter, often the public pick up this uncertainty from us, that we think this and we're not sure about this, or we're quite sure about this, but this new data came in and then we changed their mind. If you haven't got strong scientific literacy, you will interpret that as scientists don't know what they're doing, and I can't really depend on the information I get from scientists. And of course, this trickles into politics, where decision makers and politicians, instead of saying the same thing as scientists says, they will give definitive answers to complex questions. So they say, this is the answer. Even when new facts come in, they feel they have to stick with what they said at the beginning. And this is dangerous in, of course, developing our society. So for science to be for the benefit of humanity, we must include a scientific literate population. And this is really through science communication, which we should all engage in more effectively, through science education and training to all levels, so not just with students, but also to the public, and continual outreach from our centres.
So maybe we could take this opportunity to take the two questions that we have in the Q&A session. I think it's quite relevant as well. So one from Sheryl Spencer asking about CERN for the LHC data. So the access for the student needs the computer so that they can make the analysis as well. So how does CERN help with the students in really poor countries? So do you know if there are any support for hardware or for potential access remotely?
So all the data needs to be downloaded onto computers. So there's no support for students that don't have access to computers. When we were creating the data, what we did think a lot about is internet and bandwidth speed. So when you download, so the virtual machines have everything on it, so you don't need to put root on your machine, you don't have to do a lot of complicated stuff. We make stuff that's available for people who are more PhD level or undergraduates and for general public. So you can download a virtual machine that has data and software and the applications. And then we have that virtual machine in different sizes. So a really, really light version if you have a very slow internet connection. And then the other thing we try to do, along with being very aware of people's internet speeds, is also put everything onto USB keys. So when we visited to do training directly with universities and students, we could give them the key with everything on it and give these to the students. So that's what we do to address the inequality that you get. And of course, doing things to the Jupyter notebook. So that's something online. So even if you have a phone or an iPad, but even on your phone, you can do online coding through the Jupyter notebook. So then you don't need to be able to download anything. So we're trying to make it as versatile as possible. Anyone has any more suggestions, that would be very useful to hear, of course.
So in line with the open source, so that CERN is really enhancing. Very good. And second question, so from Michel Spiro, who is the president of the IUPAP. So asking about the sustainability, so the slide that you had just before, so which is a global challenge. So it needs to have indeed, it needs a global collaborative response. So don't you think that CERN type of model organization, like the collaborative, the inclusive and open, is needed so for this emergent sustainability science? Needed or requested, I would say, because this is really important.
Yeah, so I actually have this on this next CERN, so I took this is a direct quote. CERN has become a model for cooperation in terms of research because it embodies this one Earth approach of that CERN has, that the world needs to tackle global challenges. So I think that's really important and really nice. I think that most physicists now feel like that. I don't feel that I'm working for Italy or for Switzerland. We always feel a global community working together. And that's something CERN has done extremely well in embodying. And I'll talk a little bit about some other centres. But this is really absolutely an integral part of being able to work together using open science and be able to address challenges.
Thanks a lot.
Okay, shall I continue, Christine?
So that's, I think it's, yeah, it answered very well. So if you wanted to go on, indeed, we can take more questions at the end as well.
Yeah, thank you for the questions. Okay, so I'm going to talk a little bit about what I was just discussing actually on international cooperation. So this is international cooperation through science is an incredibly powerful tool for addressing global challenges. In general, it builds bridges across nations, which is hugely important. International cooperation allows, especially when it comes to facilities such as CERN, allows this kind of soft diplomacy. So between nations that maybe wouldn't want to trade with each other, or maybe have visa restrictions or other ways that they are not as friendly as others, through these soft diplomatic lines, which also includes things in the arts or in sport. Science really plays a really important role there of having countries collaborate and need to depend upon one another for these international cooperative facilities and experiments. So there's UNESCO been talking a lot about intensifying, improving scientific cooperation, and there's a big emphasis on this, especially in South-South cooperation. And I just read out this nice thing about CERN. So I'm sure everyone knows already all about CERN, but I thought I would introduce it anyway, because CERN is this incredible model of international cooperation. So I'm afraid this map's old. I couldn't find a newer one in time. But the point is that CERN really does have a worldwide interaction with many different countries. It was born at the end of the Second World War as this way of bringing together European countries, working for science, for peace, and making the countries all work together. So CERN is on the Swiss-French border, but it's not belonging to either of those countries. It's an international centre that belongs to all 23 of its member states, and their scientists use the laboratory and the facilities and collaborate with scientists from also all over the world. So CERN now has over 11,000 scientists from many different nations across the world, and of course many other scientists from even the nations left out will be accessing and working at CERN. So I'm just going to give one slide about CERN, because I mean, we could also talk about it for a long time, because CERN has done some incredible achievements. But I'm going to talk about the achievement, of course, that I'm connected with, which is with the Atlas and CMS experiments. So it's something that I think we take for granted, but we don't see how incredible the collaborative nature of these scientific experiments is. Atlas and CMS, both these giant machines, you can see CMS here on the right, they have thousands of collaborators in so many different countries that are each designing and building these extremely complex machines that we don't make many prototypes before we make the real ones. We're continuously evolving and prototyping to make these giant machines, which work at unbelievable precision. So they're an incredible feat of international cooperation between countries, putting together money to create the hardware and the software, along with scientists working together to do analysis in order to, of course, I'm highlighting the Higgs discovery here. So it's an incredible, almost unbelievable feat of human collaboration and cooperation. And of course, the Higgs paper was record-setting in the world, the most amount of authors on one paper. And of course, it wasn't just 5,000 authors on this paper. There's many more technicians and people working for the organizations that work together to make this happen, for us to find this article. So it's just really impressive that these kind of collaborative nature of humans can happen between all these different countries, and even between these two very different and independently designed detectors. Okay, and I also, of course, want to highlight the centre that I work for, the International Centre for Theoretical Physics, because the work they do for international cooperation is, of course, immensely important. So this was born in 1964. This was from Abdus-Salam, where you can see his picture up here, who was a theoretical physicist and a Nobel Prize winner. And he really set up the centre to become this hub to provide a networking collaborative space for scientists to come. And of course, in the 60s, this was during the Cold War. So there was this Iron Curtain across much of Europe, and ICTP was chosen to be just here. So this is the top part of Italy, which is called Trieste, and this is where the centre was born. So it was a real incredible place for scientists from both East and West to come to join together, to collaborate and to discuss, and very much now about being a centre and a space for scientists from all over the world, and very much from low-income countries to come and get training and meet each other and build cooperation. And talking about international cooperation wouldn't be complete without mentioning SESAME, which I think there was a talk on this colloquium not long ago. So SESAME is a fantastic centre. I was lucky enough to visit it 2 or 3 times throughout its inception. So it's incredible. So it's a light source synchrotron. You can see the picture down here. A light source synchrotron, and it is based in Jordan in a place called Alan. So if you're looking at my mouse in Jordan here, it's just north, just at the north of Jordan, a place called Alan. And this light source synchrotron has, I think it's 3 beam lines now. And it's an incredible collaboration between many countries, which are put here: Pakistan, Iran, Turkey, Cyprus, Israel, Palestine, Jordan, and Egypt. So it's about pooling resources to build scientific capacity for the region, and often, obviously, with countries that may be not so politically or ideologically or culturally aligned. Building scientific capacity within a region needs that region to be interacting and collaborating and making facilities that people can use. Light sources are not the cheapest facility to have, and of course one country can't build one on their own. You need to have a collaborative approach, a regional approach, that many scientists can use one same facility. And this is also good for creating research and career opportunities and to limit the brain drain. So of course it is a centre for excellence, but it also functions as a bridge between its diverse societies. Okay, so I think I've hopefully motivated what science can do to achieve our sustainable development through more investment into science, to progress fundamental science, to applied science, to technological transfer, to sustainable development ideals, to address the challenges. We need open science, we need open data, and we need international collaboration. So the final part, and the thing that I thought was very important, is to also look at physics for everybody. So the need actually for scientists, and to have scientists from every nation, and to make sure science is inclusive and accessible, and it should be accessible to people no matter which country of origin you're from. So internationally, of course, richer countries have always had the lion's share of scientists and the funding they put through to that, and the supportive scientific environments. This means that there's many lower income countries where they lack resources and their universities badly lack investment. So many scientists, and I'm sure many of you have met many scientists who are working in universities in lower income countries that do not have the same access to funding as our higher income country scientists would have. They don't have the same governmental support. Government often think, and especially so with physics, that universities are teaching environments. They're there to train and to teach undergraduates, but they're given hardly any funding or hardly any time, if any at all, to be able to do research. And then, of course, many students, so the undergraduates themselves, they lack exposure to research. If their faculty, if the lecturers aren't allowed to do research, how are the undergraduates going to get exposed to that? And they lack access and opportunity. So many universities, and in fact, some countries, don't have a master's in physics or a PhD in physics. And therefore, you could be an amazingly strong young physicist and not be able to do a master's or a PhD. And they're very difficult to get funding for going abroad. So all this means that we're losing valuable scientists for our scientific community. So I'm motivating here the need for scientists. So another little plot we've got here, you can see that researchers in developing countries have increased to 38% in the last 10, 15 years. But it also said that 2/3 are from China. So I haven't worked out what to do with that data. And in general, the US and China have 20% of the world's resources, closely followed by Japan and Russia. So we need nations to have strong education, scientific education, through from early childhood, through university to masters and PhD. And we in Physics Without Frontiers work with a lot of countries where the students do not have masters and they don't have PhD opportunities there. Okay, so at ICTP, ICTP do a huge range of programs from the diploma course to having associates for many students and faculty members and researchers from lower income countries. We have an outreach program called Physics Without Frontiers, which I co-coordinate with my colleague Bobby Acharya. And this project is about supporting countries mostly that are below that threshold. So do not have many scientists that are able to apply for funding. So I've got an example here with Afghanistan, fantastic students, fantastic faculty, really engaged and passionate about physics, However, most of the faculty do not get the opportunity to do masters, and very few at all get the opportunity to do a PhD. And so they lack all this opportunity and access. And so often they're not eligible to apply for many schemes that are out there. So Physics Without Frontiers is an outreach program to really try and reach all of those that lack opportunity. So we work to inspire, train and motivate physics and mathematics university students worldwide. So our aim is really at students, so undergraduate student that's at a university. I don't know how many physics students you've taught, but anywhere I go, physics students are very passionate about their topic. I think you have to be in countries where it may not lead on to a top job. You've got to really love physics. And so that's our target audience, although we do outreach with younger students and other activities. And so I'll focus on science and technology lagging countries, and we're really there to help build the next generation of scientists. So our aims are to expose and introduce, I've said here, new ideas in physics, but for example, it might be we're working with a PhD student from the Kurdistan region of Iraq who's studying cosmology, and there's no cosmology at the moment in research in Iraq. So we would work with this cosmologist and maybe some other members of the team, make a volunteer group, and then we would go and we would teach cosmology. We would give training in this and discussion about opportunities in cosmology. So it's like new areas in physics that the students in that country currently don't have access to. And we span all of types of physics and even do mathematics. So we expose and introduce these kind of new ideas and research, but we also focus a lot on training as well. So we don't want them just to learn about, say, soil science or cosmology. We want to make sure we give them some skills while we're there. So this is about transferable skills, and often that's to do with maybe programming and analysis techniques, etc. Okay, so along with giving that training to everybody in the class, we also want to identify the very strong students, as I said, that maybe are in a country where there's no masters, or maybe there is a master's but no PhD, and they don't have they don't have any connection or networks like we do as international scientists. So we provide mentoring for strong students to go on to further study. And I'll show you at the end, we have, I think, almost 300 students from our programs from over 10 years that through our programs we supported to go on to summer schools or MSc or the ICTP diploma program, went on to masters, PhDs. Many are now postdocs, and many of them also come and become volunteers back in the programs, which is really nice. So we're there to provide training. We identify and support strong students, kind of a talent search for top scientists. And then we try and connect the scientists and the universities we work with international opportunities and collaboration. So through our work, we become very used to the kind of scientific community landscape. If we're working with a university in a remote part, say, of southern Algeria, maybe they won't have that access to that kind of landscape, that kind of community. And then, of course, we work with the university with the physics department to try and bring awareness to the university and policy makers about the importance of physics. So everything I've discussed today, some countries and some universities will see physics as a dusty corridor where they're just learning stuff, and then they're not doing anything new, they're not doing any research. We try and have public events, write media articles, have opportunities to communicate what physics can do for the university and country. And so we really are a network of volunteers. You can see this is just a big screenshot of a bunch of us here. Mostly they're scientists from the country that we work with, that are working abroad doing their PhD or doing a postdoc, or sometimes we work with professors, but we mostly work with younger PhD and postdocs who are from the country working abroad. And so they provide excellent role models for the students back home. I've got a nice picture here from Gaza, which I wanted to share because it shows the kind of circle really nicely. So this is the Islamic University of Gaza. And this is a program I was running in particle physics. On the screen there, we can see Mohammed and Rami. So they are talking to the class from ICTP. They both gave a little talk about their research they're doing there. So Rami was ICTP diploma program student, and and Mohammed there is a master's student. So they were talking from ICTP, gave a review of their research and told the students, you know, about life in Italy, about their plans, about how they got on these programs. And of course, the students loved it. And I met Mohammed and Rami just 2 years earlier or 3 years earlier from this in Gaza, when they were one of these students and they were interested to go on to further study. And they're both now, Rami's doing a PhD in the UK and Mohammed is doing his PhD in Germany. So that's really fantastic. And at the left here, you can see Sahad. So she was working, you know, a student at this time, and now she's gone on to master's and PhD. So it's a really nice continuous network of students and postdocs communicating and talking to each other and supporting each other through these programs. Yeah, so I wanted to speak about that. Okay, so just to flash what kind of activities we do basically anything and everything, because each project's completely different and it's tailor-made to what the people want to do. I mean, often we do courses in some sort of theory. So this is a really nice thing that we can do. Sometimes they can be remote. Sometimes they can be delivered in 2-3 weeks intensively or over a term. Or we'll give hands-on training. So this is more experimental stuff, always with computers. The students learn a lot of skills. We do this a lot, especially using the CERN and Atlas Open Data. We might do stuff with hardware and experimental training. So transferable advanced skills, so looking at different types of programming and software you need for different types of science. And then we do a lot of just, you know, school, so a 1 week, 2 week school in, I think the example here is soil science. And it just depends on who the person is. So this is Innocent, who was a PhD student in Germany, I believe. And he worked with 2 or 3 Nigerians to come and work to deliver the school to a remote place in a remote university in Nigeria. And here, of course, we do online training and courses. And this is obviously accelerated with the pandemic. This was a program we did over 6 months with Bhutan, teaching them. This was about dark matter and machine learning. And this was in Bhutan. They had a poster presentation at the end with all their colleagues. And we joined. You can just see my bottom of me just there. We joined via Zoom because we couldn't make it in person. So Physics Without Frontiers is really about reaching out to underrepresented groups. So for example, we would work with India, but India of course has very high level scientific institutions, but we'd only work with places in India that have that underrepresented groups. So we might work with places like India, like Nigeria, like Brazil, but working with access for women and girls or access for students in the very rural or remote areas and underrepresented ethnicities. So this is a map. There's nothing different between the colors. It's just to differentiate a little bit of the countries we've worked with to date. And we're very interested at the moment to, of course, probably access more from the Central African region. Our focus in general is just lower income countries and what we would consider science and technology lagging countries. We have a focus also on countries that are in conflict or political turmoil. So just to give a few examples of our projects. So when we say underrepresented groups in rural or remote areas, so this is a project we do with the Philippines. So the Philippines has an issue, they also have quite good universities there, but many students are on islands across the Philippines that have very little access to anything scientific. And so we've been working with our volunteer team called Physics Meetup in the Philippines, where they run monthly online seminars. So of course, this isn't training. It's not going to really give a lot of education and training to the students, but it's about just connecting the students with top level scientists. And they get internationally renowned scientists to give these talks. If you're interested, you can get in touch. And we work with them. We also help with internet connections. So there's no point putting this on if you're in a remote connection, a remote region, and you can't connect. So this is a really great way of spreading physics to remote regions. We also work with very remote regions in projects we've been doing for over 8 years now, I think, in Nepal. So in Nepal, we run these annual physics schools in Kathmandu, but of course you have students that are from every region of the country. So we also, along with traveling to, so there's some pictures up here from the schools that we went to. So this is Suyog, who's also a particle physicist. And we went to give outreach and educational experiences to many small schools. But of course, we can only do so much in a short visit. During the school, which you can see the pictures from here, which was really fantastic physics school, we also do training with the young people, and they took the initiative to make an outreach network where they were able to learn how to give outreach in science communication. And then when they went to various places around Nepal or back home to their region, they could do the science outreach. And that's an incredible amplification of a project. And I've also got a few pictures here of some of the students from our school that have ended up at CERN or working with us at ICTP, and many of them have gone on to further study and PhD now. So another underrepresented group we often work with women and girls. So we all know that they're underrepresented in science. The value is 33%. I couldn't find a world percentage for physics, but we all know that it's going to be less than 33%. I would guess it's about 20%, which is what we have more or less at CERN. Okay, so this is something that we need to think about in every project that we do to make sure that we encourage women to apply and make sure that we're not biased in selection of students for certain activities, and always be aware to have a gender balance in the volunteers so that they see both male and female researchers. We've also done specific projects to support and encourage women in physics. So this is a project we did in South Africa. So this was this need to address, there was a declining number of women studying physics in South Africa. Only about 13% of women in South Africa are STEM graduates. Again, I couldn't get the number specifically for physics, but again, we can imagine it's much lower. So it's not a good percentage. So we looked at what we could do, and what we thought would have a big impact would be to make a poster campaign. So we all know that posters and advertising in general are very effective in communicating to people. Advertisers spend a lot of money to tell you that buying their car or whatever is very important. So we thought we would have these posters made. These are 7 posters that could be displayed around high schools, showing a female physicist in lots of different types of field. They have a simple quote about what inspired them for physics, or something from an interview that we had that matches it. And all in different locations, and we thought these would be an inspiration for young people. So also to put that into the back of people's minds, as imagery does, also to young boys, that women can be scientists. And this was a really nice project I did with Sahal Yaqub, who's a colleague of mine at Cape Town. And another project that we did was in Palestine. So in Palestine and much of the Arab world, there's many more women that study physics than men. So when you go and do training in undergraduates, you'll see many more females than men, and that is really interesting and really fantastic. And so to discuss their stories and talk about what they wanted to do, and all the things involved of trying to pursue physics also in a complicated conflict within the country. We did a documentary photography photo essay, which you can get the link to there. I won't go much more into it, but the students were really inspirational. We learned a lot, and it's really helped to kind of inspire and motivate younger women to also pursue science when you see so many fantastic women visually like this. Okay, so I'm going to finish by talking a little bit about conflict countries. So there's lots of countries that experience a lot of violent conflict, or it could be economic or political turmoil. And some of these countries were very strong, in fact, in science before they started the conflict. The problem with conflict is when a country erupts into war or political economic turmoil, then often the world feels like, well, we can't do anything for science when the country's not working, or, you know, and so they get completely turned away from. And then this country ends up with generation of lost scientists because, you know, they had no opportunity to study. There was no outreach programs to bring scientists to work in other countries, and students just aren't getting trained up in science. So you end up with this lost generation. So even when the conflict ends, there are not any trained scientists. So this is a huge problem and something that we are now, as a community, beginning to address. So this is our work we've been doing with Afghanistan through Physics Without Frontiers, starting in 2018, where we've been running annual schools. So you've seen this picture already. You've got names of a bunch of our volunteer team at the bottom here. Got Ensir, who's from Iran, who worked with us. This is Marco, a postdoc at ICTP. We had myself, Fawad, who is an Afghan string theorist, now professor working in Sweden. So some really nice programs that we ran, doing training, education. For Kabul University, this was one of the first times they've had a physics program being run like that. And it was really wonderful to do. UNESCO were fantastic in assisting us because obviously at the time, there was a conflict still ongoing and it was a relatively unsafe environment to be in. And the students were incredible, and we had really good schools, and we also worked to provide, so there's no masters at Kabul University or anywhere in Afghanistan in physics. So when you find really top students, it's not easy to get an MSc abroad, almost impossible really, and there's no funding. So we worked to support as many as we could with MScs abroad. And collaborated and cooperated with Iranian universities, and they've been really supportive because they have a similar language to provide MScs for the top students. And now we have over 30 students from Afghanistan have been doing their masters over in Iran. Okay, so another one to mention is, of course, Venezuela. This was more of a political instability and an economic disaster, really. So back, I think it was 2020, almost 20% of the population left Venezuela due to instability. And of course, this means you're going to get a huge brain drain of scientists. Venezuelan universities said that since 2020, they've lost around 45% of the academic staff. So this is a catastrophe for the country, of course. So we worked with a bunch, you can see all their names over here, of a team called Brain Gain, which is obviously to stop the brain drain for Venezuela. So Venezuela has so many wonderful scientists and engineers working both in the country and abroad, and many of them teamed up together, and we made these 14 fellowships over 2021 and 2022 for faculty to keep them in the country so that they did not have to flee like many of their colleagues. So this was a very nice initiative. You can see 4 of them here, the Brain Gain Venezuela initiative. And then since then, and things have calmed down a little bit, we've been working this year to do intensive physics schools because physics students have not been coming back to the universities. So to bring energy and ideas to bring students back. Okay, and just a quick mention on Gaza, you can see some really nice pictures. This was back in 2013, I think. There's been many students. Gaza is a very difficult country to work with in terms of the conflict because it's not easy for them, or in fact almost impossible, that when they get their masters or if they get admitted to ICTP diploma, they can't get out of the country and they can't get back into the country. Going in and out is almost impossible. And so ICTP did, after some, because they have extremely good students here again, that applied for ICTP diploma program and masters. And I think I can see about 3 of them in the picture here that have come on to further study. We've had so many students from Gaza that have gone to further study. They are incredible workers. And yeah, working with UNESCO again, it's been fantastic to actually help support students that otherwise would be not being able to get any advanced job to go on to be physicists. Okay, so we're talking about working with countries in conflict, but obviously many scientists have to leave their country, and this is of course refugee scientists which have We've had very much from Venezuela, from Afghanistan and Yemen and elsewhere over the past years. So TWAS does some fantastic work to support refugee scientists, and there's other organizations that work to, I think, a scholar rescue fund that help to post scientists elsewhere. And so there's a very clear justification that when refugees do have to flee a country and they are, you know, a scientist or an engineer, the host nations would do really well to identify these individuals and integrate them into universities. They would get these great scientists. And of course, this is really important for the scientists. As we all know, if we had to leave our own country, it's important for you to be able to live in dignity and continue being able to be a scientist until the conflict is over. Okay, so that was a kind of whistle-stop tour of Physics Without Frontiers. This year, it's 10 years old. We started in 2012 with just one very small project. The following year, we did 2, and then it began to balloon. This year, we've done over 20 projects. We've worked with over 150 universities worldwide in almost 50 countries in the global south, and this has impacted over 100,000 students. So you can see a bunch of pictures here. This is in Sri Lanka, having a virtual visit with CERN. This is a Women in Physics event in Nepal. This was a programming and machine learning school in Guatemala. This was soil science in Nigeria. This was cosmology in Afghanistan. This was high energy physics in Kurdistan region of Iraq. We have Zimbabwe here with climate change and safeguarding our planet. And then we had dark matter course with Bhutan. So this is just a few of them. We have thousands of photos of all the projects, and we're really interested to expand to more countries that we're still not working with. As I say, we are a volunteer network. It all depends and all rests on fantastic scientists that are passionate about doing training and outreach. And we have around 300 students that we have mentored and kept in touch with out of our programs that have gone on to maybe supported them to go to summer schools or ICTP diploma program, MSc, PhDs and postdocs. And many of them then come and become the volunteers back in their country. So they will then teach for the next generation, which is really wonderful. Okay, so just to end, I also wanted to say science and scientists is not just about sustainable development goals. As Article 27 of the UN Declaration of Human Rights said, that it's actually a human right to science. And this was very much the spirit of Abdus-Salam, who built our centre, that scientific thought and its creation is very much the common and shared heritage of mankind. Okay, so that was all I wanted to say. I'll just summarise some of the points there, but thank you for listening, and I can take some questions.
Thank you very much, Kate. It was so exciting to hear all those initiatives and the number and the quality of all of those efforts. So thanks a lot. So we had a question earlier that so Vasco from Mozambique was thinking about how he could join this PWF, so Physics Without Frontier community. So we had the website so shared with him. So since he's from Mozambique, are there any specific recommendation that you would give him?
From Mozambique? Oh, that's great. We haven't worked with Mozambique yet. So that would be great. Actually, you're right. I put the website social media mailing list, but I haven't put the email address, which is just pwf@ictp.it. So yeah, people can we put a call out every year actually, but you can email us at any time and we will get back to you and start chatting. But we do beginning of each year put out a kind of call for new applications, and that kind of deadline is around early spring. But we're always open to new connections and collaborations, because it's also useful if we work with you to develop, if we work together, so you don't just apply without us chatting.
Yeah, very good. And then we have a question as well, from Michel Spiro. So I think it's really good if he could even ask live. So this question, So I gave you the possibility to talk. Huh? So Michel, and we shortly introduce you, and we will have after, I mean, next month as well, the opportunity to have more expansive discussion. But if you could please, so set this question that we have today.
Thank you. I hope you can hear me. Is it okay? Okay,
Yes.
thank you. So I have, in fact, you alluded to this question. We are living now in a world, unfortunately, with a different paradigm. We see more and more conflicts and emerging wars everywhere. How, in this situation, can we maintain the spirit of collaboration, what you call the CERN spirit, in a world which is more and more conflicting everywhere?
Thank you. Yeah, that's a very difficult question to pose. But I guess I would answer, I mean, yes, there are many conflicts and lots of complicated political situations ongoing. The first step is, I would say, is always to connect with and work with the scientists and the students, no matter which country they're in. You know, there's lots of answers to that and lots of complicated ways of going about it. But wherever I've been, when you're working with physics students, this is not about politics, it's about the young people and about the scientists. So I think collaborating with all students, no matter where they are, we should continue to do. When things get complicated through wars and conflict, it means that the international collaboration side of things gets a lot more complex to unpack and to work out how to go forward.
Can we still, so I agree with you. So maybe I should present myself. I am the president, Michel Spiro, president of IUPAP, and also the president of the International Year of Basic Sciences for Sustainable Development. So this is why I am asking this question. Can we still maintain the spirit of collaboration? Because as I mentioned in the previous question, we need collaboration to face sustainability and global challenges. So can we consider that provided that the scientists are not acting for the war or asking the various parties to work for ceasing the conflicts, can we try to maintain collaboration and to have people working together to face the global challenges that we have in front of us?
Yeah, I think that's a really important discussion to have within the community. One example I would give for it is, for example, the situation in Iran. Many scientists in Iran who are working internationally on many different fields in physics and science face sanctions and face issues with visas and face many issues, which I think is absolutely detrimental to our, you know, we're supposed to be moving towards addressing challenges and working together. And I don't think that not working with scientists in any situation like that is helpful. But of course, in an international collaboration, when it's between governments, when it's between institutions, that is a different matter, and it's complicated and needs further discussion.
But a possibility, Kate, could be to facilitate, maybe through the support of the ICTP, for instance, some of those Iranian students to be able then to go on with further study in the different country as well. So that would be some kind of action like this that could be interesting as well to think of. And there would be also, of course, activities, I mean, that could connect to identifying as well, so those different community, and to try to connect and by network, because quite often this is what we see, is because, for instance, we have school where we gather the lecturers with the students, and then they get the opportunity to think a bit further for their future. So if we can bring to those schools students that are coming from those conflict area, but that it could be a way as well to seed some further collaboration. And with the APS, so I know that we could have certainly next month as well some really interesting development on this topic. So Michelle, I think this is exactly also some of the spirit and the idea we have in the audience. I know that Laura Green is as well there. So I don't know if Laura, you would like as well to speak. Let me see if I can do, not here. I can allow you to speak, and if
Okay, thank you.
and even if you want to join.
Oh, yeah, either way, it's fine. I've enjoyed this discussion very, very much, Dr. Shah. Thank you. I want to follow up on Michelle's question a little bit, if I can, which is there are arguments out there, and I don't know the answer, that in times when for instance, one thing that's discussed all the time is the Russian invasion of Ukraine. And a place where even Switzerland has done sanctions. And as you know, IUPAP has required that if you're from Russia, you have to sign a statement that allows you to enter the IUPAP sponsored or endorsed meeting if you claim IUPAP as your byline. And that was supported by the Russian delegation in the General Assembly. So sort of my general argument, and I could go on this for a long time, is that in a country where you're losing your rights and your freedoms and your democracy with time, does it make sense for us to be completely open across borders and boundaries with science? Or do scientists have to make a stand to hope that the extreme reaction will be better off for the scientists in the country at a later time if it's difficult now? And that's a question I've been asking.
Okay, so you're saying, is it more, as physicists in science, we should be completely open, or should we ensure that the people we're working with are able to speak out about injustice?
Yeah, and Dr. Shah, I remind you that the first 2 months of the war, CERN didn't publish, because the Polish and the German physicist wouldn't co-author with the Russian physicist. It's just a whole new world. That's what Michelle, and we don't know how to navigate it. And I was just interested in your views.
Yeah, no, yeah, it is difficult. I mean, so I don't have an answer for you. For our side of things, from what we do specifically is for Physics Without Frontiers, is we work with young people and students so that we can not have to maybe navigate the more complex arena when you're working with governments. But I would say from the scientists that I know, and in many countries, they're not as free to express themselves
Right.
as they are in other countries. And so I think it's very difficult for some, I mean, I don't know the situation in Russia, but I imagine it's maybe not as easy for people to be able to express themselves without a bit of a fear for the repercussions of that expression.
Yeah, there's
So
quite
it's
a
very
few.
difficult to navigate.
Okay. So we have to keep thinking about it and deciding.
Yeah, I think, yeah, having these discussions, and as many people have over the last year or so, yeah, I think coming to, you know, having the discussions and trying to work out the way forward is very useful.
And trying to sound as well from the UNESCO point of view, I guess that you might have as well some boundary or some limit, and try to see if those limits exist. I mean, somehow maybe possibility to tune them or to adapt them to the current situation. And it could apply for Ukraine, but for many other cases as well, of course. So yeah, we know that it already happened with, for instance, in Sarajevo. We had school as well in Sarajevo, and I see also in the audience some of the person who were really trying to help and still supporting so the physics development there. So it means sustainability, long-term involvement in those conflict area where there is some need for sure. So there is a lot to say, I would think, on that. So maybe we could keep this as well for next forum. In the meantime, and it would be great, Kate, if indeed you could potentially as well join here. I don't know if the audience, well, that would be good. Then we have just another question as well from one of our audience as well, asking, so Niru is asking if in addition to tracking how many students move on the complete master's and PhD, so how else as well do you track the impact of the Physics Without Frontiers program on the individual level, on the individual department and the community itself? And this is a fantastic project.
It's a great question. I wish we did more. There's also going to be many students that, because we give presentations about opportunities and careers, they may go ahead and apply themselves and we wouldn't track them. So we don't have a very clear picture of all of the impact and outcomes from the programs. But that's okay, because if we only know 300 students that we ourselves have mentored, we can therefore, we know that there's more. So it's only a amplification, it's only a better result. And yet, it's very difficult to kind of talk about all the outcomes and things that happen because it's not always very concrete. Sometimes we feel when you're going back every year and you've got people who are passionate about physics able to go back to their country and communicate with younger people, it brings a lot of happiness and joy to the students to be able to, as we all know, if you're learning a lot from books, to be able to do proper science and meet scientists from your country that are working away. And yeah, it's all about the connections and the networks that you get from the discussions. Sometimes more conferences or more meetings have come out of these things. At times we've been able to support getting computers or infrastructure or books to be delivered. We keep it fluid. How science works. We keep the networks able to communicate and to see what comes out. And we don't track everything very carefully. And we should do, but that's always a challenge, I think.
But maybe this is also a question from Joe, because both of you are from the ICTP. It's still field that ICTP has then all those database of students that you have been engaging with, all the email address. So for communication purpose, for scientific capacity. So you have a golden opportunity as well to be able to transmit information and to share and connect again with networks. So this is one of these aspects. There is a lot of potential for all of those database that you have collected. Don't you think, Joe?
Yeah, that's right. We do have a lot of potential. That's actually, as Kate inferred, it's one of those things that's sort of an afterthought that you never have time to actually mine what happens to the students, but we do have a lot of information. We do have an extensive database. We have, speaking for ICTP, there's lots of associates all through the world, and they're very important as contacts on the ground wherever they are. So that itself is very valuable. By the way, Kate, that was really a wonderful presentation. I mean, you really covered a lot of material. I was glad you brought up the scientific method as opposed to just the science, etc. Can I ask a question? Actually, I had a couple of questions, but I'll just try to keep it to one. So I was approached a number of years ago by one of the chairs of the Nobel Physics Committee, who works extensively in Africa, mostly in West Africa. And he actually asked me about ICTP, and his experience was that researchers, lecturers in the universities in West Africa did have some equipment. He actually provided them, but what they didn't have was the time to do the research. And I saw that on one of your slides. Mm-hmm. They simply were overloaded with teaching. And he even thought that maybe we should be buying out their teaching load rather than just giving them more equipment. I mean, do you have any thoughts on that? Was that your experience as well in certain countries? People just don't have the time because they're not really paid or they're not promoted based on research, perhaps? Mm-hmm.
Yeah, I mean, I'd say for faculty at universities, for scientists, that is absolutely the key issue in many of the universities that we work with, that they are paid to teach physics. If they do any research, it's almost expected to be in their spare time. And so, you know, they don't have any national fund to apply for. I mean, you know, this varies from place to place, but some places there's no way to apply for any money to buy your own time out or to get funding. There's very little international funding unless you're a very international already scientist. It's very difficult to work out how to get seed funding to do anything, just to buy your time out or to go to one conference, travel. I mean, they can't go to conferences, which is why having the hybrid conferences is a really wonderful movement, but still it puts them at the back foot if they're always joining remotely. So yes, that's exact. I mean, there needs to be an international fund, as we all have our, you know, in Italy, we have INFN. In each country, there's a fund where you apply for funding each year or for 3 years, and you get given that. And we're really lucky that we have that in our higher income countries. But most countries, they do not have that at all. And that will always stifle them. How are you supposed to do a master's and PhD program anyway if you haven't got the time brought out to do research?
Right. Okay, thank you. Actually, I had one more question. If I could just jump in, unless somebody else raises a hand. I'm really interested in education, inquiry-based education in particular. And you talked about student programs, but was this working through teachers, or you work directly somehow with students? What's the interface to the students? It went from CERN, I think, is where you're working.
Oh, yeah, so I don't really work in, I was talking about that as a really important need in general. Teacher training is incredibly important, yes, and do a bunch of it, but unfortunately, because CERN is very member state funded, it generally would do teacher programs in its member states, unless other countries, they have to fund their teachers. But it's very important, and it's absolutely a real need in a lot of countries. When we talk to scientists from, from a certain place, they will say the problem with the undergraduate students is that they don't have inquiry-based learning. I mean, you get it everywhere, even in higher income countries, depending on your school, and they learn by rote. And so the world of research will be very difficult for them. And of course, we've discussed how that actually impacts into how society runs. So teacher training, I think you're absolutely right. That is absolutely needed for every teacher everywhere to get access to that kind of information. Unfortunately, I think unless you go to a very nice, maybe even private school, and you have someone that did a PhD, you often won't get teachers with that much experience. So I think giving this teacher training is a really key thing that we need to do more of.
Yeah. Okay, thanks.
And indeed, and I will have as well those kind of same command question as well for teaching teacher in one sense. So this is like a way to expand and to reach out as well in a more massive way, more students in physics and science and technology. I would say both are really important in those type of countries as well. So to know and to be able to get the right type that will be directly applicable. And then there are, I know as well, some programs that are ongoing in which as well Europe is investing, and CERN as well is involved in that case. So ICTP could be as well a platform where we can exchange as well with, among us as well, those capacity. As soon as this is digital, like MOOC, this is really the capacity as well, and this open source aspect that could be more, accessible. So back to the first question that you had, Kate. So I think we need to evolve a bit on that direction to create more library, like those digital library, to connect as well, to bring more capacity and make sure that this is also, accessible in an easy way. So that will be really good. And then as well, then the other and the last one maybe would be for indeed you presented the SESAME, which was excellent. So I think thanks a lot to connect as well with the idea of this Physics Matter as well, initiated for as well with the support and to support the SESAME, so from the APS. And we had for that as well a very good forum that was prepared so in July. So I invite you as well to all cross-check so what was presented then with 18 really guests that were explaining the very origin. But we will have even more of this origin as well with Elisile Rabinovici, who will present in January as well from the inside, so from the Israeli part as well, what was really happening as well to support the creation of the SESAME. And as you said, for the Palestinian school as well that you had, so it's really something that makes a difference. And we had as well with Physics Matter, so with Joe and with so organizer for the Palestine, so two different sessions where we present as well also the support from Germany. So country can, through their institute, through their government as well, find some specific or general way as well to contribute. And the idea is really for this sustainability. This is the important part, to engage also locally, because this is what we have seen. So that with this also, for instance, naming the African strategy for fundamental and applied physics. So one way to bottom up as well, to go for this Ubuntu way as well of acting by really empowering locally as well the different scientists. So it's all about networking. That's also back to this, this capacity. So thank you very much. So any more questions, Joe? Do you think that we are then ready to introduce the next presentation for next month, so I can share my screen? Here, no. Sorry for that. And here, that's for the November. So the November Physics Matter will be on a Tuesday this time, because we have the Thanksgiving, so in America. So it means that we need to be able to plan a bit in advance, and that will give us a possibility to offset a little bit for this last 2 months as well of the year. So having so Physics Matter on the 22nd of November with a panel, excellent panel, where so Michel Spiro will come back. So with Laura Green as well, and Monica Pape-Alterelli, sorry, and Silvina, so pointed down when they will join and discuss, and we will have some live discussion to celebrate the 100 years of existence of the IUPAC. So international union, so international is really the important aspect. So we are really looking forward for that forum as well. So thank you then very much for everyone to have started and finished as well. So everything will be recorded on YouTube like each time, and we will then be able to stay tuned and stay in touch for the rest of this International Year for Basic Science and Sustainable Science Development. And you give a very good possibility to show how in that case. So let's get engaged. Thank you very much, everyone.
Thank you. Terrific. Thank you very much.
Thank you.
So,